Welcome back. In this video, we will solve this problem which is related to the radius of convergence. Let us read out what the question says. Calculate the radius of convergence and the region of convergence for the following power series. And the power series is given by this. Now let us try to solve this. This is the series which you are given. N equals 0 to infinity 2n plus 3 divided by 2n plus 5 n plus 5 into z to the n. Now when we are talking about the radius, so first we will solve the first question, radius of convergence, which is defined by n tends to infinity an upon an plus 1. So we are only talking about the coefficient and not the z to the powers. We are talking about the an. Okay, so this is something like, just like we define the series as an into z minus z0 to the power n. So you compare here that here z minus z0, there is no z0, that means it should be 0. So if this is 0, then it will be simply z to the n. So here it is z to the n, and an is this whole term. This is your an. So it is an into z minus z0, which is 0 here, whole to the power n. So this is how we define a power series, and we are given a similar structure here. So we will take the ratio of this an and an plus 1. Okay, so let us do that. Limit n tends to infinity. An is nothing but this thing only. So I will rewrite it. I will just copy it. Divided by n plus 1. So in place of n, we will put n plus 1. Okay, so we will start from here. So be careful when you have so many brackets. In place of n, I will just write n plus 1 and everything will remain as it is. Here also 2 into, in place of n, I will put n plus 1. So it's n plus 1 plus 5, and the last bracket will be n plus 1 plus 5. It is just it is looking so big. I mean, the expressions are very bigger, but they are not so complicated. When you have to find n plus 1, just you have to replace n by n plus 1. Alright, now let us simplify particular this portion. We will find a simpler version of this. So this is 2n plus 3, there is nothing to do here. We will get some simplification here by reopening the brackets. So you have 2n plus 7 here, 2n. So if you open this bracket, it will be 2n plus 2. So and 2 plus 5 will be 7. So it will be 2n plus 7. And I will open the brackets for all the cases. Here I have 2n plus 5. Okay, is that correct? 2n. Yes, it is correct. Alright, let us just check it out for a while in case we have made any mistake. Okay, it looks fine. So now what will we do is we will take n common from every bracket. So why we are doing this, that we will know very soon, but you just take n common from this first bracket. So you have 2 plus 3 by n into n into 2 plus 7 by n into n into 1 plus 6 by n. And we will do the same process in the denominator also. Take n common from every bracket. So 2 plus 5 by n into n into 1 plus 5 by n into n into 2 plus 5 by n. Now this n will cancel up and we are left with this only. Now you see here that as n tends to infinity, so you put the limit over here, 1 upon infinity will be 0, right? 1 upon infinity will be 0, so this term will go to 0, this term will also go to 0, and all the other terms will go to 0 like this, and we will be left with 2 into 2 into 1 divided by 2 into 1 into 2, and that means 1. So this is the radius of the convergence. So radius of convergence is 1, and the region of convergence z minus z0, here it is nothing but the z itself, and it is less than 1. That means you have a circle where your central point is 0, z0, but here it is 0 particularly. Radius is 1 unit. So the radius of convergence we found as 1, and the region of convergence is less than 1. So this is the region of convergence for this particular point. So this is how we find the radius and the region of convergence for each and every problems. Just like this, we will keep solving other problems as a practice. I hope I have explained well, and now we all are able to solve such problems in which we are asked to find the radius and the region of convergence. Thanks for watching.